And now, we're going to have our third keynote of QSEC. So this is my prof, Greg Wilson. I took a lot of classes with him. I know all his jokes by now, but they're really good and you'll enjoy them. Does anybody use Stack Overflow? Okay, I guess so. So I guess 2 months ago, they put together this event called Dev Days, and a few of us QSEC people were there kind of recruiting and scouting out for speakers. After Greg was done, so Greg was invited, he gave his talk, and I sent a text message to Abdullah saying, like, we gotta invite Greg back. He spoke before. We usually don't re-invite speakers so soon, but we're like, we gotta break the rules and invite him. I said that to Abdullah, and I received a text message at the same time, and Abdullah's like, we gotta get this guy back. So I guess it's kind of sealed the deal. I went to Greg, and he agreed to come. So here he is, and this is Greg Wilson.
Thank you. Okay, hands up if you've got a hangover. Yeah, that's what I thought. Hands up if you're from Waterloo. Oh, okay. I'll speak slowly and use small words. More interesting to me, and you'll figure out why at the end of the talk, hands up those people that were born outside Canada. Yeah, that's what I thought. Okay, those whose parents were born, one or other parent was born outside Canada. How many people you've got to go back a couple of generations before somebody's from overseas? Yeah. Okay. Interesting. I was born in Canada. My dad is Australian. And if you go back to my great-great-grandfather, male line all the time, the guy's name was John McColl, and he was actually shipped to Australia as a convict in 1856 on the second-to-last boatload of prisoners sent to Botany Bay. And the interesting thing about that is we don't know what he did. Right? All they recorded at the Australian end was, "Do not return to sender. Don't give us this one back." Right? The records of the court case and his conviction were all in Glasgow, and they were destroyed in 1941 during the German bombings of the shipyards. Now, there are microfilmed copies of those. Bad microfilm, done hastily 2 generations ago, that have been in a vault in Edinburgh, slowly moldering away. In there will be a couple of lines of handwriting about one John McColl explaining why he was sentenced to life in the colonies. And if any of you have an interest in handwriting recognition or that side of AI, I'd really like you to tackle this. One of the reasons I went and did my master's degree in Edinburgh was I thought, maybe I can take a stab at this. Then I looked at how much there was and how primitive the technology was. This is going back to before most of you were born. And I thought, yeah, I'll leave this for another generation. The reason I bring this up, though, is whenever I got anything wrong, whenever I did anything bad as a kid, my mom would turn to my dad and say, "This is your side of the family." There's a footnote to that. We never knew much about my mother's family until about 10 years ago. My sister got into genealogy after my dad retired, and she came back from the Ontario Provincial Archives one evening, 8 months pregnant, big smile on her face, waddles in the door and said, "I found him. I found Mom's granddad." Turns out that my maternal great-grandfather was a Methodist minister in Windsor, Ontario. And in 1892, he hopped on the overnight train headed west with all of the church's money. And the 15-year-old daughter of one of his parishioners, without saying goodbye to his wife and kids. We have heard so much less from my mom about your side of the family since this one came up. Think about how much has changed. Right now, if I want to find out about my great-great-grandfather's conviction, I'm going to have to go and read approximately 70,000 sheets of microfiche to look for 2 lines of text. I can't Google it. It took us almost 10 years to track down the record for my great-grandfather. You guys are upset if it takes more than 15 seconds to find the answers to last year's version of the question that's on the assignment in front of you, right? Some things have changed out of all recognition. Sadly, the way we build software hasn't. There is nothing that you do day by day that wouldn't have been familiar to me 25 years ago. Yes, you're using more powerful machines. Yes, you are using browsers and, oh God, JavaScript and all this other stuff. But the way you work day to day has not improved. What I'm going to talk about in the next, well, until Andrew tells me to shut up, is what we actually know about software development and how I believe it's going to change over the next 10 years. So let me start with another history lesson. Once upon a time, there was a 7 Years' War, which actually lasted longer than 7 years. The British, okay, how many people are from Toronto? I've got one more joke, and then I'll get to the talk. Okay. So the joke is the guy goes into the supermarket, gets, a couple hundred things, drops them on the 8 items or less counter. No one looks at him and says, okay, are you from Ryerson and you can't read? Or York and you can't count? Or Toronto and you think, oh, it doesn't mean me. Okay, so 7 Years' War. Britain lost about 1,500 sailors over the course of that war to enemy action, and the population of a small city to scurvy. Hands up if you've ever seen pictures of what scurvy looks like. Okay, your gums go black and swell up, your fingernails fall out, your teeth fall out, and then the bad stuff starts. It's a horrible way to go. It's vitamin C deficiency. What makes this ironic is that even before that war had started, a Scottish surgeon named James Lind had done what was probably the first controlled medical experiment in history. See, he noticed that if you pickle food, it doesn't go bad. So he thought, what if we can pickle the sailors? Well, but it's not an intrinsically crazy idea. Okay, knowing what we know now, it's a little bit crazy. If somebody volunteered to do this with me, I would, no thank you, right? But his idea was, whatever it is that's preserving the food, maybe we can get that into the sailors and it will preserve them and they won't rot, because really, scurvy looks like you're rotting alive. So he took a dozen sailors, broke them into 6 groups, and tried cider, a weak solution of sulfuric acid, bad day to be those guys, vinegar, seawater as a control, oranges, and barley water. And guess what? Within a few days, the guys getting the orange juice not only stopped degrading, they got better. So he wrote up his results and published it, and the Navy ignored him because he wasn't a proper English gentleman. It wasn't until the late 1700s, when a proper Englishman repeated this study, that the Navy paid attention. And there are a lot of historians who believe that the fact that the British cottoned on to this before anybody else was one of the reasons they came out of the Napoleonic Wars on top. Their Navy won the war for them. That blockade was the most effective instrument they had, and it all traces back to the fact that they could keep their ships at sea longer than anybody else. And by the way, this is where the term limey comes from. All right? A limey is a British sailor, or these days I guess generally a Brit. The British expeditions into the South Pacific and going around Africa all carried lime trees and planted them on every speck of land they could find. James Cook planted lime orchards all through the South Pacific so that the next set of ships would be able to get fresh lime juice so that the sailors could keep going, right? Well, it took a long time for the medical profession to figure out that controlled studies are actually the right way to find new things. Take the 1950s. Hill and Dahl did the very first case control study comparing smokers with non-smokers. You see, in the 1920s, there was an epidemic of lung cancer. Prior to the First World War, lung cancer was so rare that single cases would be written up in journal articles. It's actually a very difficult disease to get. But by the 1920s, we're seeing thousands of men with lung cancer. Now, we know today it's because of cigarettes, but that wasn't clear in the 1920s. That's the same time that cars are becoming much more widely used, so there's exhaust fumes in the air. Maybe that's the cause. There's electrical lines running overhead. Maybe that's the cause. I mean, we don't know. It wasn't until the 1950s that Hill and Dahl took over, I think it was about 1,500 British doctors, split them into 2 groups, and looked at those that were smoking and those that weren't, and looked at the incidence of lung cancer. Right? It's the longest running medical study that's ever been done. It didn't wind down until 2001, when the last of the original subjects finally passed away. Okay? They published their results, and we discovered a couple of things. Number one, it was unequivocal. In the mid-1950s, smoking causes lung cancer. Hands up those people who smoke. Okay, stop. Please. I hate burying students. Second, the other thing we found is that most people would rather fail than change. Most people are so scared of change that they will come up with all sorts of excuses as to why they shouldn't do it, even when the evidence is put in front of them that it will make their lives better. All right? This quotation, what happens on average, is of no help when one is faced with a specific patient. That's a quotation from the head of the British Medical Association when this study was published. What's the point of doing all this statistics and all these controlled experiments? I've got a man with lung cancer in front of me. Your statistics are of no use. Completely misunderstanding the point. The point is that if we ask a question carefully, and if we're willing to be humble enough to admit when we're wrong, to look at the data, then we can find out how the universe actually works, and then we can do things based on that knowledge. All right? There's a professor at McMaster, Sackett, coined the term evidence-based medicine in 1992. And today, randomized double-blind trials are the gold standard for medicine. You cannot put a new drug or a new treatment on the market unless you've passed that test. And I strongly urge that you go and have a look at the Cochrane collaboration site. How many people here either believe that vaccines cause autism or know somebody who believes that vaccines cause autism? Right? There will be a few, okay? The raw data from over 50 studies is available for you to analyze on the Cochrane collaboration site, along with all of the papers based on that. You don't have to take somebody's word for it. You can go dig through and do your own analysis and find out that there's no signal there, that there is no causative correlation. Right? This is wonderful. And it would have been possible before the internet, but the internet certainly brings it to a wider audience. You can go and have a look at climate data. You can go and have a look at economic data, and you can see for yourself whether there's cause and effect, and if so, whether it's strong enough that you want to act on it. Well, now let's take a look at software engineering. This is Martin Fowler. He wrote the book on refactoring. He's way smarter than I am. You know, I read his blog. Every single time he posts, I learn something. Very deep and careful thinker about software and software design. And last summer in IEEE Software, he had an article on domain-specific languages, this notion that you build a tiny language in which the solution to your original problem is easy to express. And in that he said, using DSLs leads to improved programmer productivity and better communication with domain experts. Okay? Now, I want to show you what happened here. One of the smartest guys in our industry made 2 substantive claims of fact in an academic journal, and there's not a single citation in the paper. Not a single footnote or reference. There is no data to back up this claim. And now, please note, I'm not saying that Martin's wrong in his claims. I'm saying that what we have here is a Scottish verdict. Right? Courts in Scotland are allowed to return one of 3 verdicts: innocent, guilty, or not proven. Arguments in favor of DSLs, arguments in favor of functional programming languages making parallelism easier, or agile development leading to tenfold return on investment, or whatever, are unproven. It doesn't mean they're wrong, it doesn't mean they're right, it means we don't know, and we should be humble enough to admit that. Okay? Carrying on in that same article, Martin says, debate still continues about how valuable DSR is in. I believe that debate's hampered because not enough people know how to develop DSLs effectively. Crap. I think the debate is hindered by low standards of proof. Right? Listening to computer scientists argue, listening to software engineers in industry argue, it seems that the accepted standard of proof is, I've had 2 beer, and there's this anecdote about a tribe in New Guinea from one of Scott Birkin's books that seems to vaguely be applicable. Therefore, I'm right. Well, no. Sorry, but that's not proof. And you should have higher standards than that. The good news is we are starting to see things improve. Since the mid-1990s, inspired particularly by the work of people like Barbara Kitchenham, there's been a growing emphasis in software engineering research on empirical studies. I was at the International Conference on Software Engineering in Vancouver last May. Almost every paper that described a new tool or a new development practice had in it the results of some sort of field study. Not just, I built this and I think it's cool, but I put this in front of 20 developers for 3 weeks and here's what happened. Yes, it's difficult, sometimes very expensive to do these studies. Yes, they can be flawed or incomplete. I mean, most of the studies in the literature use the standard academic guinea pig, which is undergraduate students desperate for free pizza. That definitely biases the results. I mean, I think it was interesting that when Andrew's announcing the party, the first thing he says isn't, there's going to be a great band. The first thing he says is free food. He knows what you're after. Okay? A lot of these studies are flawed. They're incomplete. But the standards are going up every single year. We are learning more and more from fields like social psychology and perceptual psychology and econometrics. How do you do these studies well, and what constitutes proof? It's almost impossible now to get a paper about a new tool or a new methodology in software engineering accepted in a top-tier journal or conference without having taken it out and tried it in the real world, and that's progress. Right? Here's an example of what I mean by results. This is Jorge Aranda and Steve Easterbrook from 2005. I'm going to break you into 3 groups. Oh, conveniently, you have broken yourself into 3 groups. Okay. I'm going to give you a 2-page spec of a change that I want made in a website. You're the control group. You get the description of the change I want made, and in the middle of the 2nd page, it says, I'd like to give an estimate, but I've got no experience with that. We'll wait for your calculations. Okay? You guys are group A. You get exactly the same spec, but instead of those 2 sentences, I insert, with no highlighting, no underlining, I don't try to draw attention to it. It's in the middle of a paragraph. I say, I've got no experience with software projects, but I guess this will take about 2 months to finish. You guys get the hint that it's going to take about 20 months. Every other piece of information you've got about the existing project and the scale of the change is identical, and you don't know that this is what I'm varying between the 3 groups. Guess what happens? The lowball group estimates an average of 5.1 months, regardless of how much experience they have in the domain, how much experience they have in software development in general, what technique they're using, how familiar they are with the tools. None of that has any statistical bearing on the results. That hint buried in the middle of a paragraph on the 2nd page drives the difference between 5.1 months, 7.8, and 15.4. It's called an anchoring effect. It's well known from psychology. And what this means is all the work that's been done on software estimation to date is pretty much pointless, because what the engineers are going to give us back is what they think we want to hear. Okay? Isn't that a useful thing to know before somebody tries to sell you an estimation tool or methodology? Right? And there are lots of people doing that. Hands up if you're from IBM. Okay? How many people have come in and said, we need you to fill in these forms because we're building our estimates to put together the Gantt chart. And what we do is we start with wild-ass guesses that you pulled out of thin air, but then we've got all this software to assemble them to make them look meaningful. Right? If I sound cynical, it's because I am. Okay. Now, those of you thinking about graduate school, hands up if you're thinking about grad school. Okay, every time I present a result, you should be thinking, what's the next study I would do? Here, we've got a beautiful study that shows an anchoring effect on this kind of time scale. What happens if we're doing agile development and the time scale is a day or a couple of weeks? Am I getting the same percentage error, the same percentage effect in my estimates? If so, I'm not going to be any better over the lifetime of the agile project because, yeah, on any given iteration, I'm only off by a few hours. But over the course of the year, those hours add up to be weeks or months. Right? We haven't done that study. We don't know what happens if instead of saying, I think this is going to take a few months, I tell you it's going to take a few hours. Do you become more percentage accurate or not? That would be useful to know. If you do become more accurate when you're estimating shorter things, that's a powerful argument in favor of using agile methods. I've seen people make that argument over and over again, but there's no data to back it up. Let's go get the data and find out if we're right. Here is what is probably the most widely misquoted result in software engineering. All right? The best programmers are up to 28 times more productive than the worst. You've all heard this, right? Except the number has varied. Some people say 10 times better, 100 times better, 40. I'm going to pick a number that's big enough to be impressive, but not so big that you're going to doubt me. Right? Do a Google for this on the web. You will find dozens of variations on this claim. You will find entire books written about hiring programmers and doing startups that say, look, all you need is a few really, really good people, right? Because they'll be 100 times more productive than them. Right? And mentally, of course, we're all putting ourselves at one end of the bell curve. We're not saying, oh yeah, I'm one of the stupid ones. Okay, well, let's take this claim apart, shall we? First, the study was done in 1968. Hands up if you were alive in 1968, okay? Right? The world has changed a little bit since then. Does batch programming with punch cards behave the same way as interactive programming on a Macintosh with an interface that looks like it was designed for a 3-year-old by 3-year-olds? Anyway, not a fan. Yeah, you see? People say that your generation is less religious. Now, you bring up Mac versus PC, you'll find out about religion. Okay. Second, the original paper does not describe how productivity was measured. We have no idea what their metric was. Third, if you compare the best to the worst, you're going to exaggerate any effect. I mean, if you compare the best driver in the world to the worst driver in the world, the best driver is infinitely better because the worst driver is dead. okay? I don't drive, and there's a good reason for that, right? We should be looking at standard deviations around the mean. I mean, this is just bad statistics. This is awful statistics, right? Turns out it was 12 programmers for an afternoon, none of whom had any formal training as programmers, because it's 1968. Everybody's a self-taught programmer in 1968. They start as mathematicians or physicists or linguists. Best programmer I ever worked with. Had actually, his only higher education was 2 years at a rabbinical college in New York. He said, yeah, basically programming is about being very precise about the words mean and making, splitting hairs. We've been doing this longer than you have. Right? He was very good, okay? Now the next major study, done in the early 1980s, was 54 programmers. Wow, that's a lot more people. The longest subject ran for 63 minutes. Right? So all of the claims you're reading about the relative productivity of programmers can be traced back to 12 people in 1968 for an afternoon or 54 people for an hour. How confident are you in those claims now? Meh. Okay, so what do we know? We actually do know a fair bit. I'm not going to tell you what we know. Instead, I'm going to encourage all of you who are currently Twittering to switch over to Google and look at the work of Lutz Perschelt. He's a professor in Germany, and he's been doing some very good work on productivity variations between programmers, the effect of language. He's got a paper just out. What's the effect of the web programming framework on people's productivity? Yes, these studies are expensive. They're hard to do. But let's face it, bringing a new drug to market costs anywhere between $500 million and $3 billion today. All right? By the time you do all the studies, by the time you're in production, ballpark, $1.5 billion. Okay? I don't need that. I'll take 10% of that. For $150 million, I believe I could do dozens of interesting studies in empirical software engineering, the results of which would probably have, what, 5%, 10% improvement in the productivity of the average programmer? Okay. So I can take a $500 billion a year industry worldwide and boost productivity by 5%. What's that as a return on $150 million? 5% of $500 billion over $150 million is lots, right? I have a degree in mathematics. I don't actually calculate with numbers. I just, right? Big O of lots, okay? One of the pieces of folklore that Lutz actually confirmed is that productivity and reliability depend on the length of the program text independent of the language level. You will produce roughly the same number of working lines of code if you're writing in assembly per hour as you will produce in Ruby or Scheme or Perl or Java. Right? Your output in terms of text per hour is roughly constant. That's a pretty cool result. It argues that we ought to be using the highest level language that we can, because you can do a lot more with 10 lines of Python than you can do with 10 lines of assembly. The problem, of course, and I'm seeing a couple of people frown, is, as somebody once said, platform-independent programs have platform-independent performance. Right? If you're writing at a very high level, your performance is going to be right in the basement. But at least now we can start doing what engineers have done in other domains for at least a couple of centuries. We can start making trade-offs. If I use this very high-level language, I'm going to need 10 times as many servers to get performance, but my code will be working next Thursday, not next year. Okay, now it becomes an economics question. And engineering is really what happens when you take science and economics and try to put them together. Okay? It's nice to have the data on which to make decisions. Here's another classic result with some implications. This goes all the way back to Barry Beam's work in the mid-1970s. Result number one, and this has been validated in lots of other domains by lots of other studies. Most errors are introduced during requirements analysis and design. That's the hard part of software. It's not writing and debugging any particular piece of code. It's figuring out what are we supposed to build and how are the pieces going to fit together. Okay? Second, the later a bug is removed, the more expensive it is to take it out. If you can catch a bug in the design phase, it costs an hour to fix. You catch that same bug after you've coded, it could be 10 hours. You catch it after you've released to customer, not only are you on the wrong end of a lawsuit, but it's cost you 100 hours to fix. It really is orders of magnitude as you go from one stage to the next. Why is this interesting? Well, it explains, I believe, the two major schools of software development. Pessimists and optimists, right? The traditional people and the agilistas. The pessimists say, look, we're going to tackle that hump in the error curve. If we can eliminate bugs in the design and analysis phase, so that fewer get through, our total cost will come down. So let's put our effort up front, where the hard bugs are, and cut the number that are getting out here to the expensive part of the fixing curve. That makes perfect economic sense. The Agilistas' view is, let's take that curve and shrink it and then stitch lots of them together. The total area under the solid curve in that bottom diagram is much less than the total area under the dotted curve. If I do iterations of 2 weeks, maybe the total time I spend fixing bugs is less than if I do one long iteration of a year. These are both testable hypotheses, and there are groups around the world right now gathering the data to test them. It would be wonderful to know which, if either, is right, because then you could build your software development process around facts instead of around bestsellers. So why does this matter? Well, here's a rather disappointing, at least to me personally, snippet of conversation from a bulletin board at the University of Toronto a couple of years ago, 3 years ago now. We were talking about why there are so few women in computing. And a senior student with very good grades who's about to get a bachelor's degree from Canada's self-proclaimed best university, don't rag me on this, please, just let that one go, right? He said, yeah, I just always believe there are fundamental differences between the sexes and women just aren't as good at this stuff. Okay, so I said, what data are you basing that opinion on? His reply was, and I quote, "It's more of an unrefuted hypothesis based on personal observation. I've read a few studies on the topic and found them unconvincing." Oh, okay. Unrefuted hypothesis based on personal observation. That's a long-winded way of saying bullshit. Okay? I have read a few studies on the topic and I find them unconvincing. Which studies? He didn't reply to that part, despite several promptings. Okay, let me show you what it looks like when grown-ups are having this conversation. Chechi and Williams, Why Aren't More Women in Science? This is an absolutely brilliant book, even if you don't care about gender inequity in science. You've got 20 top-flight researchers, roughly half of whom believe the explanation is nature, it's genetic, and half of whom believe it's nurture. They're writing alternate chapters. They're arguing with each other. Here's some reasons why there's intrinsic genetic bias that make women either less capable or less interested in computing. And the next chapter is, yes, that's very nice, professor. Here's what you got wrong. Let me explain your own results back to you. And the next one says, well, actually, you should have interpreted the data this way. This is a grown-up conversation between well-informed people who are merciless, absolutely merciless, in picking apart one another's logical flaws. How many of you have ever been part of a debating society? Okay, you know what this is like when somebody comes at you and will, oh, I see a little hairline crack, I can get the crowbar in and there goes your argument. This is the best example I've seen recently of what science looks like in action when people who've spent 30 years tackling the problem don't know what the answer is, but they are intimately familiar with one another's work and reasoning. Right? They're all very polite, but it's that kind of icy politeness you get at the wedding when people bump into each other and go, oh, yes, how are you, right? It's nice. Just to pick one result out of this that I didn't know. Susan Dweck's work, absolutely brilliant work out at the University of British Columbia. I think she's still there. I'm going to split you into 2 groups this time. I'm going to have you do a task that you haven't done before. I'm going to tell you guys that research shows there's a genetic component to this. There's an aptitude. And if you have it, you'll do well. And if you don't have the aptitude, you'll do less well. I'll tell you guys that research shows that this is entirely practice-based. The more you practice, the better you'll be. Guess what? You guys will all do worse. Even if I say, we've got evidence that shows that men are better at this than women, the men will do worse. As soon as you believe that there's something intrinsic in the aptitude, then the first time you can't do something, the first time it's hard, you'll say, well, I guess I just don't have the gene. You'll talk yourself out of doing it. It doesn't matter whether you're in the in group or the out group. Both groups do less well when they believe there is something intrinsic in the ability. Now think about how we present programming ability culturally. Right? There's very strong signals that are being picked up from a very early age to say, well, some people got it and some people don't. Right? And it's got a lot to do with which washroom you use. It's not surprising, given that we're seeing the, 5-to-1, 6-to-1 ratio in undergrad classes, the 200-to-1 ratio at Dev Days in November. Right? It's nice to have people doing this kind of research. Don't you wish there was that kind of research about programming? So here's a few results that we've got that you ought to be taking into account. Woodfield, 1979, it's been replicated a few times. If you increase the problem description's complexity by 25%, you double the complexity of the solution. It's nonlinear because of interaction effects. If I add just a few more features, how big your solution is and how hard it is to make it work will double. You've all run into this, right? You all know that adding one more feature makes everything else break. The beautiful thing about this is that we can drive it backwards. If I'm allowed to pick one quarter of the features that the prof has asked for in the assignment and say, no, I'm not going to do those, it will dramatically reduce the complexity of the assignment. If I get to throw away a quarter of the requirements, I can bring in better code a lot faster, and it's not a linear effect either. Maybe this is why Agile works. Maybe it's because at each stage, they're using much smaller chunks and getting rid of more interaction effects. That would be a really nice thesis. Anybody who's interested, I'm easy to find. Okay, a result you've probably heard, biggest causes of project failure are poor estimation and unstable requirements, neither of which seems to be improving. Right, there's a lot of arguments over the Standish group, the chaos reports, all of the data that's been collected, but we certainly don't see any evidence that as a profession we're getting any better at estimating how long is this going to take. We're certainly not getting any better at nailing customers down and saying, what exactly did you want? Right? Hands up those people who read Dilbert. Okay. One of the very first Dilberts I read was passed to me during a meeting. 6 of us sitting around a table. Somebody bumps me and slips me a piece of paper on which the pointy-haired boss has come over to Dilbert and said, I want you to make our website look more webbish, but not too webbish. How long will that take? Right? Okay. At which point, the guy in the suit sitting across the table can see us looking and says, what have you got? Show him the piece of paper. I swear, upon my grandfather's grave, he looks at it and says, I don't get it. We were doomed. Okay? Here's another result. Now, I haven't seen this one replicated. I'd really like to try. Okay, this is a result that comes from the group at Boeing from the late 90s. If you have to rewrite more than about a quarter of a software component, you're actually better off throwing it away and starting from scratch. If what you want to do is get functionality working out to the customer, there seems to be a point at which trying to move things around and refactor is actually going to be more total work than just saying, okay, we've got new requirements, let's just burn this out and write what needs to be in that hole. I haven't seen this one replicated. I would really like to. I'd like to know, does that apply across different programming domains? They're looking at flight avionics systems. All right, they're looking at the software that goes into airplanes. They've got very stringent safety and reliability requirements. Does it apply to Flickr? Does it apply to Facebook? I don't know. I'd like to know. Wouldn't you like to know? We've got to replace this. Yeah, we need to fix it. Well, the rewrite's going to half the lines. Okay, we're burning it out, right? Engineers should be able to do this kind of thing. Here's another classic result from the 1970s. The work was done at IBM. Hour for hour, the most effective way to get bugs out of code is to sit and read the code, not to run it and not to write unit tests. Okay? Code review is the best technique known for fixing bugs. Get somebody else to read your code. 60 to 90% of errors can be removed before the very first run of the program. And hour for hour, if you've got a choice between writing more unit tests or reading somebody else's code, read the code. Now there's a footnote to this, Jason Cohen's work, which was done at Cisco. Turns out that all of the value comes from the first reader and the first hour that they're looking at the code. Having 2 or more people read through the code isn't economically effective. It's better off having the second reader read something else. They're not going to uncover enough new bugs to make it worthwhile. Similarly, after about an hour of reading code, your brain is full. Okay? Now, how much code can you read in an hour? Like really read, line by line, picking it apart. A couple hundred lines, good guess. Right? It varies from person to person. It does improve with practice, but a couple of hundred lines is about as much as you're going to be able to get through and critique when you're looking for more than just, oh, the indentation's off. When you're actually thinking about what are the interactions between this piece of code and something else way over here. You're actually thinking deeply about the code. That argues very strongly that every change to the program ought to be sized small, that we ought to work in lots of little steps, right? Well, take a look at successful open source projects. Look at Mozilla, look at Linux. Most of the progress they make is little patches. And if you submit an 800-line patch, they'll come back and say, break it into pieces. We can't think about the interactions of these changes with what's already there if you give it to us in one big lump. And the first time this happens to you, you'll say, but it doesn't make sense if I break it into smaller pieces. The answer is, nobody else is going to be able to make sense of it if it's one great big steaming brown thump of code. Okay? I've been looking at too much student code. Okay, so shouldn't our development practices be built around facts like this? We've got data, right? We actually do have data, so let's design our tools and the way we program around the way people actually work. Here's another personal favorite of mine. Conway's Law from the 1960s was meant as a joke. A software system reflects the organizational structure that built it. Basically, if you've got 4 teams working on the compiler, you're going to get a 4-pass compiler, right? The software will reflect the organization. It's not the organization that reflects the intrinsic structure of the software. It was meant as a joke. It turns out to be true. In that way, it is a lot like Perl. Thank you, thank you. I'm here all week. So, Jim Herbslett at Carnegie Mellon did a lot of the work. There's a variation on this that was published just last year that I find fascinating. Nachi Nagapan and Chris Bird went through all of the data that Microsoft has on the development of Windows Vista. They've got everything. They've got chat logs, emails, who phoned who when, builds, changes to the code. They've got an enormous volume of data about the construction of that operating system. Okay? What they were looking for was things that would predict post-release fault rate. Is there something I can look at before we send the CDs out that will tell me how many bugs there are going to be? Well, it turns out that the physical distance between developers has no impact on post-release fault rate. There's this myth that you have to have the team physically co-located so they can all talk to each other. The data does not support that. You can have teams split between Bellevue and Bangalore and Berlin, or you can have them all physically located in the same shed in Vancouver, and it will have no impact on post-release fault rates. What does have an impact? How far apart the people are in the organizational chart. Even if they are physically adjacent, if they are far apart in the tree diagram that represents Microsoft Corporation, you're going to have a higher post-release fault rate. Why? Because if they're far apart in the org chart, their managers probably have different goals and are probably too busy to talk to each other at that level. If you've got a team that is geographically distributed but reporting to one person, it's better than having a team that is physically co-located but reporting to different people. Okay? Now, that's a really cool result. Okay? Because now I know that it's okay in my startup to get some guy in Bucharest doing stuff. I don't have to worry about the fact that he is 9 time zones away, as long as he's reporting to me. Okay? Having a whole bunch, I mean, this explains, in my mind, anecdotally, this explains why so many big software projects at big corporations are such absolute fracking disasters. How many of you have ever worked for a company that had more than 10,000 employees? Okay, I was sharing an anecdote with Doug Crockford. One of the reasons I left Hewlett-Packard was a startup I was part of during the last but one tech bubble got bought by Hewlett-Packard, and it wasn't a comfortable merger. At one point, we actually did have somebody from corporate headquarters say to us, you know, we can't just have people running around doing the right thing. Because there's rules. There's rules. There's procedures to be followed. You'll follow the procedure even if it's the wrong thing, right? This result substantiates those kinds of anecdotes, and I think our development practices should be built around them. Now, a word of caution, and this is something that many people, particularly many people in politics, seem not to understand. Science does not move forward all the time. You go forward, you back up, you go into a blind alley, you make mistakes. And the difference between science and religion is that we acknowledge our mistakes and change our minds publicly. They just wait a couple of hundred years and then claim that, yeah, we always said that. Okay? So here's an example. Are there things about software itself, code metrics, number of lines of code per method, coupling between classes, et cetera, et cetera? Are there things that we can measure in the code before we release a piece of software that will predict its post-release fault rate. Lots of papers from starting in the late 1980s saying, yeah, we can do this for object-oriented code. We can look at large projects, look at the bugs that were found after it was released, look at this metric that measures, you know, how many library imports are there per class or something like that, and we've got positive correlation. Well, then a professor at the University of Ottawa in 2001 published a paper called The Confounding Effects of Class Size on the Validity of Object-Oriented Metrics. There's statistics in this paper, which means most of you will never read it, but I'll summarize it for you. Okay? Turns out that almost all of the published metrics people were using correlate very strongly with how many lines of code do you have. The bigger the program, the more likely it is that you will have methods that are too long, that you will have instances of classes being too tightly coupled, and so forth. So instead of doing a single-barreled correlation where I look at the metric and the post-release fault rate, I do a double-barreled correlation. I separate out the effect of number of lines of code from the effect of the metric, and guess what? None of the metrics published prior to 2001 have any predictive value beyond that given by just counting the number of lines of code with a command line WC. All right? This is actually, as disappointing as it is, a very powerful and useful result because it raises the bar for an entire field. If you want to claim that you've got something you can measure in code that will tell me how buggy that code is, you have to do an analysis that's at least this good. You have to do this to be taken seriously. Right? That's cool. It means that not only are we generating new information, we are generating better ways to tackle problems. We are raising the standards so that the next round of results will be more reliable. Really what I think of when I think about this stuff is the equivalent of folk medicine. Right? Folk medicine is this notion that we go down to the Amazon, we look at, you know, the paste made from chewed leaves that the, native inhabitants are putting on wounds to prevent infection and see if there's a useful antibiotic in there. Lots of drugs, digitalis for example, have been found this way. You go and you take a look at unschooled practice and see what actually works. A lot of engineering happens this way. Right? You go and you take a look at what people in the field are actually doing, bring it back in the lab and say, okay, why does this work and then can we make it better? We need to do this with software engineering. I spent 19 years in industry before taking an academic position, and I gotta say, there's a whole lot of stuff that people in industry do as a matter of course that does not appear in your textbooks, certainly is not taught in your classrooms, and isn't part of the academic literature, despite, or in my dark moments, I think, because it actually works. And I think the road ahead for software engineering, the next decade of software engineering, is to go out and say, what's actually working in the field? Can we figure out why? Because if you ask people in a startup to explain their success, they're almost always going to be wrong, because they've only got one data point. They're going to attribute it to the fact that they chose Ruby on Rails, right? And they're going to ignore the fact that they're actually religious about doing pre-commit code reviews for version control. So let's compare across a large number of places so that we, as academics, can do the synthesis so that we can say, all right, I see a pattern here. What is that pattern, and can I feed it back to you? If you're thinking about graduate school, this is where we're going to add value. Okay? So, how do we get from here to there? How do we change the discipline? Well, as a reformed Trotskyite, I believe the best way is to subvert the system from within. So let's back up 3 years. 3 years ago, in conjunction with Doug Crockford and a few other people, I helped O'Reilly put out a book called Beautiful Code. Hands up if you've seen the book. Okay, those of you who haven't, please go buy it now. Okay? All of the money goes to support Amnesty International. We don't make a dime, right? They need your money more than you do. So, what we've got here is 34 chapters. In each chapter, one or two people pick the most beautiful piece of code they've ever seen and spend a few pages explaining why it's beautiful. Funny story that happens to be true. I approached Rob Pike, one of the creators of Unix and C and that whole generation of tools, and said, will you write a chapter? And he said, oh, I've never seen any beautiful code. I don't think I could do this, right? But if you find any, let me know, right? I passed this anecdote on to Brian Kernighan, one of the other creators of Unix and C and that whole set of tools. So what he did was pick the very first regular expression matcher that Rob Pike ever wrote in C, and he used that as his example, right? There's lots of really good stuff here about what code is worth looking at, what code is worth reading. Right? There have been a series of books since then, one on software architecture, one on data visualization, one on security, one that's just out on testing. Right? Yes, it's possible for testing to be beautiful. You just have to have the right frame of mind. So, we are currently in production, rounding up material, for a book that I was going to call Beautiful Evidence, but damn it, Edward Tufte got there first. Okay? If you haven't read Edward Tufte's books on information visualization, absolutely you should. They're beautiful to read. They're chock full of useful information. He's a very careful, deep thinker. The only thing I'd say is that he's actually written the same book 3 times. Right? Pick any one of the trilogy, now tetralogy. Right? But he picked the title Beautiful Evidence, so we've got to come up with a different one. We've got a whole bunch of people who are going to pick one thing that we believe we know is true about software development and explain why we believe it. What is the evidence to back up this claim or that claim? What's the facts? Okay, where did that data come from? How did we process it? Why do we believe this study but not that one? Okay. The main goal of the book is knowledge transfer. I want you to know these things so that you can build your development processes around them, so that you can make sensible choices about tools and languages based on evidence. Right? I also want a much better software engineering textbook than the ones that are on the market right now. Hands up if you've written a software engineering textbook. Okay, good. Then I feel perfectly comfortable saying that I have, last time I counted, more than a dozen on my shelves, and they're crap. They have almost no relationship to what I did for 19 years building applications that people would pay money for. How many of you voluntarily draw UML diagrams when you are thinking about software? Really? We can get you some help. No, seriously, I've only ever worked, in 19 years, I've only ever worked with one programmer who actually used UML to think, and he was Russian, and he would read a book on knot theory before tying his shoes. He needed formalism, right? I think that having what's likely to be 350 pages of here's something that's true about software development and here's why we believe it is going to be a more useful textbook for you than what's out there right now. My real goal underneath all of this is to change the standards of the debate. I want your generation to be more cynical than it already is. I can't believe those words just came out of my mouth. I want, the next time somebody comes to you and says, we're going to learn Haskell because then parallel programming is easy, I want you to say, citation, please. Where's the evidence? Not where's your anecdote. Not where's your 10-line example that you threw together and wow, look how easy this is and will you buy my book, please? No, I want you to apply the same standards that you would apply if you were picking an acne medication. Has somebody tested this? If so, who? Do we trust them? How many people here trust studies done by big pharma companies? Right. How many people here have ever picked up a software tool based solely on the evidence given by the person who created it and is now trying to sell it to you, or at least persuade you to adopt it because then they earn karma points on Stack Overflow? Right? I see a few hands going up in the air. I want to change the debate. I want you to insist on evidence. Right? These are people who are contributing to the book. Right? There's going to be a lot of stuff in here. We hope to have it on the shelves in May, which probably means June because there's the word software in there, which means everything slips. Right? And this is the result I want. I want you to, I'm starting in software because that's the field I work in, but I need you. I don't just want you, I need you to have higher standards for proof and evidence and argumentation than my generation had. I want you to be doing that. And this is why. I don't know if you've noticed, but we're in trouble. Whether it's global climate change, running out of water, running out of oil, drug-resistant diseases, there's a whole lot of bad in your future. Right? And right now, if you listen to the public debate, it is almost evidence-free. People just make shit up. Misquote things, right? They think this is a political matter, and eventually, yeah, it is, but the politics is supposed to be grounded in evidence. You're not supposed to convict a man of murder without evidence, and you're not supposed to release somebody who's been convicted without evidence. You're not supposed to make decisions about whether we're going to build wind farms in Ontario without evidence. The fact that somebody is willing to take you out for a really good lunch and buy you a golf club membership is not evidence. The fact that it fits with your existing political ideology is not evidence. That's my daughter, down there. Cutest child on the planet. All right? I want to see some heads nod. I'm going to repeat that. Cutest child on the planet. Could I have some? Thank you. Right? I am so happy that she looks more like her mother than she does like me. So, I want her to inherit a better world from you than you're going to inherit from us. And the only way to get there is to have you think a little more clearly. Now, I'm 1 minute over. Can I have 2 more minutes? Okay. Hands up if you think you know what university is for. We may have to turn off the camera for this bit. This bit's not public, right? I'm a professor. I'm not supposed to tell you this. Really, what's university for?
Gives it a base, like stuff which I can't learn on my own, but the rest is
Wrong. I mean, good, right? That's a public story. You know, that's what we say when the grandparents are in the room, but that's not what university is really for.
producing and sharing knowledge.
Producing and sharing knowledge? No. Okay, I'm
Generating university profs.
generating jobs for university profs? Close, close. Okay, I'm going to tell you what university is actually for. A piece of paper. Okay, when I said I want your generation to be more cynical, don't go that far. Okay. When I was an undergrad, I went to high school in a little town in British Columbia. There was no senior math or physics classes, right? There weren't enough students who wanted to take it. There were 80 students in my high school. Okay? So when I went to university, I thought, this is where I get to learn stuff. It's about the stuff. I'd read about this thing called calculus. I mean, I'd heard this mentioned in science fiction stories, and it's really cool, and I want to learn that, right? I fairly quickly figured out that university wasn't about the stuff. By the time I finished my bachelor's degree, I thought university is there to teach us how to learn. Right? Because they keep throwing us into situations where there's this impossible volume of stuff you have to digest, and they don't teach you how to learn it. It's just, here, swallow. Right? So by the time I finished my bachelor's degree at Queen's, but I'm better now, I thought, okay, university is about teaching you how to learn. And then I went to grad school, and by the time I was done that, I thought, no. University is really here to train us how to ask good questions. Undergraduate education is a price that universities pay in order to get grad students. Right? It's how we prepare you so that you can go off and you can do research. And the point of research really is to find a good question that's going to move human knowledge forward. There's lots of bad questions out there. There's questions that are either pointless or too hard to tackle. And finding something that's worth answering and within reach is an art form. And the only way to teach it to you is to have you do it for a few years. All right? So I thought that's what university is for. And that got me through about the next 15 years. And then my daughter was born. I went back to teaching at the University of Toronto, and now I know what university is for. Okay? I will share this secret with you, but, okay? We are trying to teach you how to take over the world. Because you're going to have to, whether you want to or not, sooner than you think. My parents are retired. They are both fairly frail. I look after them. I turned 47 on Monday. I've become the grown-up. When the hell did that happen? I didn't sign up for this. You guys have a problem, you can flip to the back of the textbook and go and talk to a prof. You can go to somebody who's probably got the answer. I run into a problem, I have to go and talk to a mirror. Right? There is no higher authority that I can appeal to any longer. I've become the grown-up. I am older than several federal cabinet ministers. I was graduating from high school at the time that the guys who founded Google were being toilet trained. There are, last time I checked, 34 heads of state on this planet, people who are running countries who are younger than me. And I'm only about 20 years older than some of you. Now, 20 years feels like a long time. Let me tell you, you draw breath 3 times, it will be gone. You will be the one that everybody's looking to for answers. You will be the one trying to make the decision when there isn't enough information, when it hasn't been done before, and when there's nobody else you can turn to. You'll be running the world, and the world you will be running will be a scarier place than the one we've got now. You'll be dealing with all the mess my generation is leaving behind because we're too fat and happy to fix it. I'm not going to get rid of my car. I'm not going to stop flying. I'm not going to, 3 cents on the dollar in income tax to save our grandchildren from global warming. I don't know, right? That's the world you're going to have to run, whether you want to or not. That's what we're trying to get you ready for. I'm starting in software because it's the field I know. It's the field where I think I'll get listened to. But I want you to apply those same standards for evidence and reasoning to everything. Because if you don't, the world my daughter inherits from you is going to suck. Okay? Thank you for listening. Good luck. question. In the back. Big voice.
Yeah, I was wondering two things. What are your thoughts on, you seem to be in the engineering part of things. What are your thoughts on the craftsmanship movement? And second thing, when you think about screwing calculus and orienting the science circuit around stats instead.
Okay. On the first one, what do I think about the craftsmanship movement? What evidence do you want me to cite? Is there any evidence that it makes a difference? If so, please tell me what that evidence was. Right? There isn't. Doesn't mean it's right or wrong. It's wonderful. You know, every 10 years, right, we have to completely turn over our way of doing things in pretty much any field. Not because it needs turned over, but because it's the only way that we can say, well, look, we're innovating. Right? We innovate for the sake of innovating. Talk to anybody who's in public education. Every 10 years, there's a new bandwagon that rolls through. And after you've seen 3 or 4 of them come by, you just learn to keep your head down and wait for it to pass. I want some evidence. If the craftsmanship movement leads to better software at lower cost, great, show me the data. As far as getting calculus out of the way, I don't know, I haven't looked at it. My undergraduate degree is engineering and math. I started in electrical engineering, but although you can't see it from where you're sitting, that scar is from picking up a soldering iron the wrong way around twice in one afternoon. The second time I had my hand under the cold water tap, the lab tech came over and said, Greg, have you thought about the software option? Probably saved my life. Okay, one more. Sure, go.
I really agree with all the moving away from anecdotes towards attempting scientific studies, but as far as I'm concerned, especially towards testing, developing methodologies, there's really no way to run an experiment that isn't in some way sophisticated.
Okay, so which experiments that have been run do you disagree with? Do you think we're fundamentally flawed?
No, my problem is, so suppose you want to compare two development methodologies using DSLs versus not.
Okay.
Then you have two groups. Or you start with one group, you have them do the task one way first and then another way second.
So I'm going to interrupt you right there. Which of the studies that have been done in this area do you think are flawed? You haven't looked at any of them, have you?
Okay.
No, but, sorry, that was a yes or no question. Have you looked at the studies? Okay.
I have not.
Go and do that, and then come back and we can have an informed discussion. I'm not trying to shut you down. I'm trying to say that people have been doing these studies in business since the 1950s. How many people here have looked at Harvard Business Review? Okay, that's the watered down pop version of the real research. The real research looks at exactly these things. What happens if we change part of the process? Does it make us more productive? The fact that they are doing that in sales and marketing rather than software development is irrelevant. There are just the same personal variations in circumstances. The reason that I drive a Japanese car rather than an American car is because Japanese companies in the 60s and 70s were paying attention and the Americans weren't. Okay? The data is out there. Those studies can be done. Yes, it's tricky. Yes, you have to be careful.
What are some good ways to actually conduct those studies?
I've got a book I want to sell you. If you can wait until May, right, I will have a collection of the best people in the world explaining what's been done and why you should believe it. That book is not aimed at academics. It's aimed at you. It is not aimed at their peers who've already read their papers. It's aimed at people in industry. It's aimed at students. It's aimed at you. So if you can wait till May, I will give you a longer answer than you really want. Do I have time for one more? Yeah, sure. Go ahead. Nice T-shirt, by the way.
Thank you. I'm not sure if I heard this correctly, but in passing in your presentation, you mentioned about, I thought I heard you say that you're a communist.
No. I'm not a communist. Trotsky. Very different thing.
Okay.
It's the difference between bluegrass and country.
Right.
One is authentic, the other is not.
Right.
And I'm over all of that.
Trotsky is still.
Yeah, these days it's World of Warcraft.
Right. But so I'd like to hear some evidence as to why you think it works.
Oh, subverting organizations from within?
No, Trotsky.
Oh, sure. The difference between the Trotskyites and the Bolsheviks was the Trotskyites believed that a small number of people who are clever and coordinated can seize the reins of power. They don't have to go into the streets and do revolution there. If you can get the right 3 people on the right committee, you can change the world.
Well, where's the evidence for that?
How many people here are Russian? Right. Okay. How many people? Okay. Better question. How many people here have worked in public education? Okay, many of the changes that were seen in the 1960s, particularly in the United States, were the result of a concerted effort by a small group of people to get certain things done. And the way they got that done was they got themselves elected to school boards. We've seen the same thing happening in the States in the last 15 years. The reason you can't teach evolution in Texas, despite the fact that 70% of Texans in polls would like it included, is because those 70% of people don't care enough to get elected to school board. The people who care enough to go out and run for public office have a focus issue. And you only need to have half+1 of the school board membership on your side to say, well, we're not going to include textbooks that talk about this Darwinist stuff. So there's an example that's going on right now.
Study.
Beg pardon?
Where's the study?
Of this work? Barnes and Phillips in 2002. Before you go on with that, so the scary thing about that is that if you look at Alberta, Saskatchewan, and the interior of British Columbia, we're seeing the same thing happen right now. Anti-science populists have learned from what happened in the United States and are making conscious efforts to get themselves elected to school boards. Many are trying to get themselves elected to local health boards in the UK because they want to make sure that abortion becomes as contentious an issue there as it has become in the United States. You look at the point, it's like a software system. If all of your data flows through one point, that's where you attack. If all of the decisions about what goes into a classroom or what is provided in a public hospital go through this one committee, that's where you get elected. How many people here have taken part in a rally against the prorogation of Parliament? Yeah, it's going to have absolutely no effect. You want to have an effect? Go and get yourself onto a campaign committee and fight there. That's where you will have an effect. There's a reason why I'm targeting you guys with this book. You are going to be running companies and software development teams 10 years from now. Isn't that a scary thought? I don't know, are you planning industry or going to go to grad school?
Industry.
Okay, so in which school are you at?
Carleton.
Carleton, okay, so you're going to head straight to the top. Good school. Okay, you're going to go, it's a very good program. You're going to go right to the top. 10 years from now, you will probably be in charge of a team of half a dozen people. You'd have to screw up pretty badly not to. Okay? I want you to have this stuff in your head then. It means I have to wait 10 years to have the effect that I want. I'm willing to be patient. Any others? Please. I know, I'm way over time. I'm cutting into your lunchtime, but it means the people from the other room are getting all the good food.
As much as I do agree with everything you said, but to me, personally, I started off in physics when I came to school. So none of this really seemed new to me. I didn't realize it was new. Most schools, basically, they make breadth requirements. Computer science, they consider you as science, so you have to take your humanities, social science. Would you not agree that computer science doesn't fit as nicely as a science it's not treated as?
Shrug. We now get into games. You tell me your definition of science, and I'll tell you whether computer science fits your definition. If you want computer science to be a science, you will choose a definition that includes it. If you don't want computer science to be a science, you will choose a definition that doesn't. I don't care. What difference does it actually make? Ask me whether I think we ought to be turning out engineers rather than scientists. Absolutely. Engineers are legally accountable for their work. It's up to you. Okay.
Sorry, just on that point, one of the frustrating things for me, I'm in software engineering, and one of the very frustrating things is when I see a civil engineer build a bridge or a mechanical engineer build a car, they actually are held accountable, right?
Yep.
Like if a bridge breaks, you can find the civil engineer and get him in trouble. For us, when we make like a piece of software, like an operating system or something, and it breaks, nothing happens to us, right? We could get fired or something, but there's no process. It only happens when you make a nuclear reactor software and that breaks and people die.
There's Steve McConnell has written a fair bit about this, and there's a professor, Tim Lethbridge at Ottawa, who's also written a fair bit about this. Strongly suggest you go and look at their stuff. The proportion of people in engineering disciplines who are professionals in the sense of having a PEng varies from a low of about 10% in civil to a high of about 70% in mechanical. Right? I don't think there's any one future ahead for us. Some of us will have professional designations and be legally accountable and be repeatedly examined because we're working on things where that's needed. Others won't. I don't see any reason for somebody who's slapping together pages for MySpace, right, to have to pass a calculus exam. On the other hand, I'm really happy that the people who are building telecom systems do. Right? I don't think there's just one future. Last question, just before we go, since we got into politics. Hands up if you're a student member of the ACM or the IEEE. Okay, those are the two bodies that are arguing your case where it matters. Okay, the people who are standing up for you and saying, yes, we should be legally accountable, or no, we shouldn't. The people who are explaining to legislators what data privacy actually means and how it can be enacted, and why so much of the legislation that is out there that is supposed to protect you is actually bad and ineffective. Those are the two professional bodies that speak for you. If you want to be heard, blogging is going to have absolutely no impact on the political process. Right? Neither is starting a Facebook group. If you want to be heard, if you want to have some influence over your own future, join those organizations and influence them. They are the elderly guys in suits who go and sit down with the minister to say, okay, here's what we, the professionals, think should be done. Right? Dreadlocks and a nose ring does not get you into the corridors of power. Right? It doesn't. I'm sorry. That's just the way the world works. Right? The people in the Ontario legislature, here in Quebec, in Ottawa, everywhere, are going to be looking to professional bodies to say, this is what should happen next. And if you're not part of it, then other people are making decisions about your life outside your control. Hands up if you're happy with that. Okay, $25 a year, you can have a vote. It's not a lot. Thank you all once again, and good luck.